our webs. Left web, we have our right web, and then we have our bottom flange. Okay, then we are quickly going to do our so we're going to have our width, depth, and this will be our area. So the top will be 12 and 1. Check again, 12 and 1, so that's 12. And then our left web, the width is 1. And then I'm going to take the depth as 6. Okay, so this is 6, 1, 6, this is 6. And then the bottom flange, the width is 6 and 1. So it's 6. So if I add all of them, I have 12 plus 6 plus 6 plus 6 is equal to 30. Then from here, I'm going to take the Y bar, and my reference is from the top. Okay, so 1 divided by 2 is equal to 0.5. 1 plus by 6 divided by 2. 1 plus by 6 divided by 2. So 3 plus 1 is 4. This is also equal to 4, the same thing. Okay. So then we have 1 plus 5. So 1 plus 6 minus by 1 divided by 2. So 1 plus 6 minus 0.5 is equal to 6.5. Then we're going to take our A Y bar top. So 12 times 0.5 is equal to 6. 6 times 4, 24, 24. And 6.5 times 6, 39. So this is 6 plus 24 plus 24 plus 39, 93. I do it again, 6 plus 24 plus 24 plus 39, 93. So Y bar is equal to 93 divided by 30. So 93 divided by 30 is 3.1 inch. Okay, now let me teach you how to confirm whether this is right or wrong. So if you want to confirm right or wrong, okay, you can also do Y bottom. So Y bottom means datum is from the what? Bottom. Okay, so this will be 0.5, right? So 5 plus 1, 6 divided by 2 is 3. 6 divided by 2 is 3. And then you have 5 plus 1, 6 plus 0.5. This is 6.5. Okay. Then you calculate your A Y bar bottom, right? So you have 12 times 6.5 is equal to 78. 3 times 6, you have 18 twice, left and right. And then you have 6 times 0.5, which is 3. Okay, so you have 78 plus 18 plus 18 plus 3 is equal to 117. So 117, let me do it again. 12 times 6.5, 78. 6 times 3, 18. 6 times 3, 18. 0.5 times 6 is equal to 3. So 78 plus 18 plus 18 plus 3 is 117. So this one from top. And then if you do Y bar from bottom, you will have 117 divided by 30 is equal to 117 divided by 30 is equal to 3.9 inch. Okay, so from bottom. So either you take from the top or bottom. If you add these two values, if you add 3.1 plus by 3.9, this is equal to 7. And 7 is correct because 1 plus 5 plus 1, that's why equal to 7. Okay. Can we always assume that the joint will be the weakest link and not calculate and consider other modes in example number 1? Akura, for the first example that we had, okay, we are given 3 values. We always must check. Okay, we always must check. This is training. Okay, training means you are doing a course. Okay, you always have to check. Even though you later on when you're an experienced engineer, you still have to check. Okay, so that's standard practice. That will answer your question. Right. So from here, we are going to calculate our I Z for the top flange. Okay, so this is the width 12 1 cube over 12 plus by area of 12 multiplied by 3.1 minus 0.5 squared. Okay, so 12 times 1 divided by 12 times 1 divided by 12 plus 12 times by 3.1 minus 0.5 squared is equal to 82.12 inches to power 4. Let me do the 12 times 1 power 3 divided by 12. 12 times by 3.1 minus 0.5 close bracket 12, 82.12. Then you have I of the web is equal to 1/6 cube over 12 plus by 1, just multiply by 6, 3.1 minus by 4 squared. Okay, 1 times 6 power 3 divided by 12 by 6 times by 3.1 minus 4 bracket. 6 power 3 divided by 12 plus 6 times by 3.1 minus 4 close bracket squared. 22.86. I'll do it again. Yep. Okay. Go on. 2.86, correct. Then IZ lower flange. So 6, 1, 3, 12 plus by 6, 3.1, Y bar is 6.5. $69.86. Let me do it again. $69.86. So IZZ is equal to 82.12 plus by twice of 22.86 because the web left and right plus by 69.86. 2.12 plus 2 times. It's equal to 197.7. Okay, so from here we would like to calculate our Q. Okay, so Q will be equal to, let me get the diagram down. Okay. So we know from the top is 3.1 inch our centroid. Okay, so Q is width multiplied by depth, Y bar, right? So we're still looking at the top. So the width is what? 12, 1, 3.1 minus by 1 divided by 2. So 3.1 minus 0.5. So it's 31.2 inch cube. Okay, so from here we can calculate our Vy. Okay, so we're going to calculate 50. So that we're going to use Q is equal to VQ over I. Right, so we found our Q, which is equal to 50. V is what we want to determine. Q is 31.2. I is equal to 197.7. So V, so 50 times 197.7 divided by, so 50 multiplied by 197.7 divide by 31.2. So 50 times 197.7 divided by 31.2 is equal to 316.8. Okay, pound of force. And this is at the top flange. Okay. So next we are going to consider the bottom flange. Okay. So why do we consider the bottom flange? Okay. So remember, the next time failure will occur. Okay. So the bottom flange, the failure will occur here. Right? For the bottom flange. Right? Like, so we know that over here is our terminal. We know that the shear flow is coming in this way. Yes or no? Right? So this section over here, right? This member over here will what? Distribute the what? Shear flow. Right? The member will distribute the shear flow. That is why you take that the flange. Okay, you don't consider the web. Now if we are to consider the web, where the failure of the web will occur, it will fail at the what? Centroid, right? Right, at the web you will fail at the what? At the centroid. Whereas at the flange, right, you will fail at the joint. And this is because the shear flow, the member will distribute the shear flow, right? Because over here, this is our terminal, right? The terminal at the center in terms of thin wall, the shear flow is equal to 0. Then it goes outwards. You got shear force build up or shear flow to build up. So that is why you consider the flange. Okay. So from here, the same thing. Q is equal to the width is 6. 1 multiplied by we have 3.9 minus by 1 divided by 2. Okay. So 6 times 1 times by 3.9 minus 0.5 is equal to 20.4 inches cubed. So the same thing, the same formula will apply, where Q plus 50 is equal to, I'll write down the formula, okay? So 50 is equal to V or Q. What am I doing, Eugene? Don't rush, because I have 2 more examples to show you. It's VQ over what? I. So this is equal, so V is equal to that's what we want to find. Q is equal to 20.4. I is equal to 197.7. And then this whole thing will be equal to 50. So therefore V is equal to 50 multiplied by 197.7 divided by 20.4. Okay, so 50 minus 197.7 divided by 20.4 is equal to 484.6 pound of force, and this is for the bottom flange. So over here we can conclude that the control is by V is equal to 316. You take the smallest value, okay, pound force, and this is due to the top flange. Okay. So again, it's not the difficulty. Which first moment of area to consider? Okay, I'll do another example. Yeah, do another. I hope to finish like more example. So let me insert another page.